Combining fractions. It's the third of 6 algebraic manipulations you can use when evaluating limits algebraically. The strategy for evaluating limits in this manner will be to first try direct substitution. But if that fails, which it often will, we want to think of combining fractions as one of the tools that can help us proceed in finding the limit. Let me show you an example of how it works. Take a look at this limit. We're going to try direct substitution first, just like we always do, which means I'm going to take this limiting value of 0 and try plugging it in for every y that I see on the inside of the limit. And when I do this, I get 3 over 0 plus 1 over 0. And guys, you're not allowed to have a 0 in the denominator. You certainly aren't allowed to have 2 different zeros in 2 different denominators. Direct substitution is failing miserably. So we're going to need to use something different, and that's going to be harnessing the power of algebra. We're going to combine the fractions that are on the inside of the limit. We have 2 fractions separated by an addition symbol. Why not try adding those together? It's sort of the same thing as before. Like if you see something that factors, then try factoring it. If you see something that expands, try expanding it. And now if you see 2 fractions separated by a plus or a minus, then try adding or subtracting them. And it's almost like the limit, tells you what to do in a sense. And sometimes, that's not always the case, but, in this case, it's almost like the limit's telling us to add those fractions together. It's speaking to us. So let's go ahead and do that. I'm going to try to add those fractions together and see if something magical happens to fix the problem of the 0 being in the denominator. First things first, I want to rewrite my limit. I am starting over and indicating to everybody that I'm going for a new attempt here. Now, as far as adding these 2 fractions together, how do I do that? How do I add 2 fractions together? And what needs to come to mind is common denominator. The denominators of both the fractions we're trying to add have to be the same in order for them to be combined. And in this case, they are both different. So we are going to need to make sure that they have the same denominator, and then we can combine them. And hopefully, at that point, something happens to make this limit all work out. So the first thing I want to do when trying to get this common denominator is make sure all of my denominators are factored. And as you can see here, this left-hand fraction, the denominator is not factored yet. So I'm going to take that first step and factor that left-hand denominator. And when I do that, I get y minus 3. And then, of course, the 1 over y over here just hanging out. Now, I need to create identical denominators. Not, sort of the same, like exactly the same. And the good news is they both have a y right now. And so that's good. It's just that this left one has this y minus 3. So we sort of have to force the one on the right to also have a y minus 3. And then they'll both have the same thing. So that's what we're going to do. We're going to force that issue by multiplying. So I'll rewrite everything here just to be thorough. And now I'm over here. I'm going to multiply, like I said, the denominator of this fraction on the right by y minus 3. Now, if you can see that this fraction on the right will have the same denominator as the one on the left, which is exactly what we want, common denominators. Now we can add the fractions together. But before I add the fractions, I need to make sure that I do the same thing to the numerator as I do to the denominator. Otherwise, I'm changing the value of the expression, and that's not okay. So essentially here, I'm multiplying by y minus 3 over y minus 3, which is the same thing as multiplying by 1. And multiplying anything by 1, it doesn't change the value, so we're all good in that respect. So the next thing I want to do, let me move down just a bit here. The next thing I want to do is clean up this multiplication over here on the right. So I'm going to go another step. The left-hand fraction staying the same for now. Nothing's going on there. And then recall that you multiply fractions by just multiplying across. So I'm just going to multiply across, but don't multiply out the denominators here. You want to keep the denominators in factored form, and you'll see why in just a few minutes. Keep those denominators in their factored form. Don't try to redistribute. But there you have it. Both the denominators are now identical, and now we can combine the two fractions through addition. And that's exactly what I'm going to do. Carrying through the limit again, because I'm not applying the limit yet. I'm just changing the way the inside of the limit looks. But now combining these fractions, adding them together. How do you add two fractions? Well, now that their denominators are the same, the numerators are going to combine, and the denominators just kind of absorb into one version. The denominator stays the same. There you have it. So now the two fractions are combined into one. And take a look. Now there's already stuff that is happening here. You see the 3 and the minus 3, those are going to cancel. So the 3 and the minus 3 are going to cancel. And beyond that, going another step just to clean up that cancellation that just happened, I have y over y times y minus 3. And something else is going to cancel now. And this is really the cancellation that is going to make everything work in the end. This is the cancellation that's going to fix the problem of the double zero up in the direct substitution step. We had this sort of double zero situation that was happening. So two different zeros and two different denominators. And that was being caused by this factor of y that was in both. The blue factors of y. That's precisely what was causing the 0 to appear in the denominator. And now, once we combined those fractions together, there was still that term of y on the bottom, but now it's canceling with the y that remains on the top that sort of ended up being there because of the nature of how the two fractions were combining. And that's sort of, we design these limits as teachers. We design these limits so that those things happen, and you get that sort of special cancellation that's going to make everything all work out. So now that that's happened, we can go ahead and clean up the cancellation of those y's on the top and the bottom, and I'd be left with 1 over y minus 3. And at this point, now that I had that sort of major cancellation, I want to go ahead and try plugging in the limiting value once again, which is this 0. I'm going to try plugging it in for every remaining y in the inside of the limit, and you can already see how it's going to work just fine. We're going to get 1 over 0 minus 3, which is minus 1/3. No more 0 in the denominator. And that fixes the problem, and that's indeed the limit, negative 1/3. So if direct substitution fails, and you see a pair of fractions separated by a plus or a minus sign, then you got to try adding or subtracting them. And that also means you need to make sure you're comfortable with creating a common denominator, as you must do that when combining fractions using addition or subtraction. So now we have 3 tools to consider when direct substitution fails: factor and simplify, expand and simplify, and now combining fractions. The next twist involves simplifying a complex fraction, which is the 4th algebraic manipulation. I'll show you just how it works in the next video.